Hello, statistical scholars. Today I'm going to show you a brief example using the sampling distribution. So I'm going to start by reading the example, make my plan, and then I'm going to take it into action. So the president of a firm believes that 30% of all come from first-time customers. A random sample of 100 orders is selected. Describe the sampling distribution. What's the probability the sample proportion will be between 20 and 40%? What's the probability the sample proportion will be greater than 35%? And then find the confidence interval for the proportion of all customers. All first-time customers. I'm missing my hyphen there. Whoopsie. So the first thing I'm going to do here is I'm going to um, start by looking at describing the sampling distribution. So since my sample is random, I have one of the requirements for the sampling distribution be normal, check. I should also check the success failure condition. So real quickly, I'm just going to calculate 0.3 times 100, which is my number of successes, and that's 30, that's bigger than 10. 0.7, which is Q, because 1 minus 0.3 gives me 0.7, gives me 70 customers, so that meets my second condition. I'm assuming all customers are independent of each other, so therefore I meet my last condition to use the sampling distribution. So that means the first thing I know is that I know its shape. It's normal. Okay, so now that I know that it's normal, the next thing I gotta ask myself is, oh, okay, I got shape down. The only things I need to know to be able to do the sampling distribution, once I know that it's normal, is I need to know its center and I need to know its spread. So we know the center for all normal distributions for the sampling distribution of proportions is just your true proportion P. In my case, that's 30 or 30%. I'm going to write it as 0.30 just to remind myself where it's coming from. The next thing I need to do is I need to calculate the standard deviation, which is the square root of PQ divided by sample size. So that's the square root of 0.3 times 0.7 divided by 100, which when you calculate that, I have a calculator just sitting by that I'm using for this, is 0.04582. I'm going to do more than I think I'm going to need for the spread just because that number is so small. I don't want to accidentally lose any accuracy. So now that I have the center, sorry, my bird is chirping, and the spread, I can go ahead and calculate these probabilities. So I want to know what's the probability between 20 and 40%. So just to kind of picture this, I know it's normal. Here's my center, it's 0.3, and I want to find what's the probability it's between 0.2 and 0.4. So I'm going to turn to Minitab to calculate this, which is one of the ways you can calculate probabilities. So I'm going to open up Minitab. And this is the way I like to calculate normal probabilities. I go up to Graph, down to Probability Distribution Plot. And then we always use view probability. You'll never actually use these three to do anything. I mean, you kind of could do that. We're always going to use view probability. It'll become second nature to you. I'm going to hit OK. It's already set on the normal distribution. There are other things than the normal in here, but that's the one we want. So I'm going to put in my mean, which is 0.3. Sorry, oh no, I'm on my standard deviation. I'm going to put that in 0.04586, and then my mean, 0.30. This defaults to the standard normal, which is mean 0, standard deviation 1. I'm going to go to shaded area. And here's where you need to be careful. I hope you can see this. Well, for some reason, my pictures are tiny on my laptop. So its default is to be on probability, which is I know the probability. I'm going to input it, and the computer is going to output to me the score I'm interested in or the value I'm interested in. So notice the P's or the probabilities always appear above the graph for all these options. We don't have that. We have particular values we want to know what their probability is. So I'm going to click X value, even though these aren't really X's, they're proportions, but whatever, it's the value or score of the distribution, not the probability. So notice these appear on the bottom. These are tiny, so I don't know if you can see that quite. So those correspond with being scores or things that appear on the bottom. And since I'm doing in between two, I want the middle. So I want between 20, and remember we're using proportions, so I'm using proportions, and 40. I'm going to go ahead and click OK. And it's going to produce a graph for me. Oh, it looks like it's 0.9709. And again, values above the graph are probabilities. Along the edges, these are score values. Notice it marks my mean for me. It always does that. You can actually pick this up and move it around if it's in an inconvenient spot. So, fun facts on that one, I guess. All right, so I'm going to go back to my notes and write down what I know. And that's that the probability, and I like to use big P's for probability to distinguish them from proportions, is I'm doing the probability that my sample proportion, hat for sample, is between 0.2 and 0.4, and I found that to be 0.9709. Lovely. So now I want to find the probability that my sample proportion, again, hat for sample, is greater than or equal to 0.35. So I'm going to need to turn to Minitab to do that as well. So let's go back to Minitab, and I'm going to use the same thing. I'm going to go up to Graph, Probability Distribution Plot, select View Probability, hit OK. My stuff from last time is still in here, so I have the proper mean, proper standard deviation. I'm going to go ahead and hit Shaded Area. It's still set on X value, which is good because I want to know if it's greater than 0.35. So I'm going to click the right tail because it's going to share the area to the right, or things that are greater, which would be things greater than 0.35. I'm going to go ahead and hit OK. And let's see, where is it? Oh, 0.1376. It's not very big. Alrighty. Let's go back to my notes and make note of that answer. Oops, I missed my 1376. Alrighty, last but not leastly, we are asked, what is the confidence interval for the proportion of first-time customers? So I'm going to do a confidence interval now. So I'm going to go back to Minitab to do my confidence interval. Now you could start off with, I'll take my P and I'll add and subtract my margin of error, which is the same as I'm going to do my P plus or minus my z-score times my standard deviation or standard error, whichever, which I got earlier. This is 0.3 plus or minus 1.96 because that's the z-star that corresponds to 95%, times my standard deviation, which I found earlier. And that's how you would do this by hand. But I'm lazy. I'm going to use Minitab. So here we go. Back to Minitab we go. And they're not too far off from each other. I just like Minitab because it's going to be a little bit more accurate. So I'm going to go to Stat, Basic Statistics. Oh, my thing moved. Basic Statistics, down to one proportion. Notice this is a proportion, and it's one sample. This 2 is the number of samples. We will do a 2 proportion test in this class. All right, the first thing it asks is, are your samples in columns? That means, is it in my data sheet? It is not. It is not in my data sheet or worksheet. I have summarized information. So the next thing it asks me is number of events. This is the number of successes that happened. So since I am successful at a rate of 0.3, the number of successes is 30 because there's 100 in my sample. Number of times I tried, 100 in my sample. All right, the next thing I want to do is I want to hit the options button. And this is going to give me all my options that go along with doing a 1 proportion sample. So notice it asks for my confidence level, 95%. That's the one we want, so that's good. The next thing up is it asks me for what's my alternative. Don't worry about that. That's going to come up later in the next chapter. And then last, it's going to ask for method. We are actually using the normal approximation method in this class, not the exact method. The exact method is just something a little bit different that accounts for the slight difference between doing a binomial, which is what this technically is, a sum of binomials, and using the normal instead. We're using the normal approximation of the binomial, so that's the one we want. It's also the one that my stat lab will take answers for, so make sure you use normal approximation and not exact. This is the #1 place where I see people make mistakes. So like exclamation, hearts, and stars, and whatever it is to make yourself notice that I need normal approximation mode every time I'm using proportion testing. And that's always going to be true. All right, let's go ahead and hit OK, and then hit OK again. And it's going to produce this output for us, which I'm going to copy over. Donk. All right. Once again, it has scrolled up on me. I'm just going to click in here somewhere and paste this sucker. All right. So I want to write all over this to let you know what's going on. All right. First up, answer. There is my confidence interval. So if we were to appropriately write an answer for this, we would say we are 95% confident. I hate my cursive. That the proportion of all customers who are first time. See why I should just type this. I type these in your Minitab notes. Sorry, your case study notes is between 21.12% and 0.38. Sorry, I have an eraser. Jeez. 38.98%. And I'm rounding how they typically write decimals. Usually it's just one, but I can only 2 places. But yeah. Okay, couple other things this gives you in your output. Notice it reports your sample proportion in here. That's your p-hat action. It tells you your number of successes, that's NP, and your number of trials, that's just N. It also remarks to you, hey, you did normal approximation mode, just in case you forgot. This is also typical of things you're going to see as we go further in the class is I'm going to write all over Minitab output to let you know what all of it means. So there's that. Alrighty. So if you'd like to see more examples on how to do it not by hand but by Minitab, go to your first case study because that one's longer and has more in it. Fun times. Have a very nice day. I don't know. I gotta find a way to end these that's clever. Like, I said peace out Girl Scout in the last. Let's try. Now go do some math.